Saxon Algebra 1 lesson 104. We're already to the end of our second week, week 27. 1/3 of the way done. All right, let's take a look at what we're talking about here, abstract rational equations. Yes, I said it right. Our last lesson was about rational equations, so let's figure out what this abstract means. Okay, that's a lot of letters, isn't it? Just a single one. It's a lot of letters. John writes something in the problem that I want to add here. He writes this. Why does he write that? Well, it's because we have to make sure that our denominators don't turn into zeros. So he sets up this little impermissible value statement for us, and we need that in order to do this problem because we can't let those ever turn into zeros. So he's told us that. Now we don't have to worry about it and we don't have to calculate it, okay? So he's being our buddy and our pal. And in all of these problems, he writes the impermissible values so we don't have to worry about it. Now, here's the thing about this that makes it abstract. It's all letters. And there's no way to solve this for a number because we've got all these letters. So we're kind of stuck, except John tells us one more piece of information. He tells us what letter he wants us to find. I'm circling that because that is the only thing that gives us direction in this problem. Without this information, we'd be stuck. We would have no idea what to do. This tells us, oh, okay, so what we're going to try and do is rearrange this so that the m is by itself on one side of the equal sign and everything else is shoved on the other side. So we want this tells us we want our problem to look like m equals and then whatever, right? That's what we're going for. We want m to be by itself on one side of the equal sign. So that's our long-term plan. How do we do that? First thing we have to do is blow up the denominators, which I abbreviate as denoms, and I always remember it looks almost like demons, doesn't it? Because they're nasty little things. All right, how do we do that? We spent a lot of time working on that last time. We find the LCM. The only way we can find the LCM is to multiply, so we know it's going to be mx. We multiply every term by the LCM, mx, mx, mx. We cancel what we can and multiply whatever's left over. I can't cancel any of these, so it's all going to stay. Now I rewrite m plus bx equals cmx. Okay, that looks good. Next thing we do is we gather the desired letter, in this case is m, to one side. We want all the m's on one side, and any terms that don't have m, we want them on the other side. So here's an m and here's an m. Why don't we swim this m this way? And now the m's will be on the right. We'll have bx equals cmx minus m. P.S. Spoilers. You can do this any way you want. Like we could have decided, no, we want the m over here. Let's bring the cmx over to this side and move the bx over there. That's fine. You can do it however you want. There are no rules on that. We just want all the terms that have, I should write this, gather terms with desired letter to one side, right? Because we can't just pluck out the m's. We have to take the whole term. Okay. 3, factor out the desired letter. Okay, that's going to be just looking at this side. See how we have CMX minus M? By definition, every term on the side we set it up to be on will have that letter in it. So we're going to factor it out. When we pull an M out of this, we'll have CX left. When we pull an M out of this, we'll just have 1. Make sense? You can always check your factoring by distributing. CMX minus M. Beautiful. This side stays the same. Now, we're going to divide away. This CX plus 1, we don't want it. We want the M by itself. We want this CX minus 1 to go away. So we just divide by it. Right? That's gone. And now look, there's M by himself. I'm going to write it the way I think is cuter. I'm going to write M equals BX over CX minus 1. This is what we were hoping to do. Get M by itself and shove all the other stuff to the other side. And this is the right answer. We also need to add, since we have letters in the bottom, technically we need to add another impermissible statement. CX minus 1 cannot equal 0. Okay, so there's a little addendum to our answer that we need to add. Wow, what do you think? I'll tell you what, most students, and this includes me, when you're just messing around with all these letters, it makes you feel really smart. What I like about it is that it's actually easier because we just have letters. We don't have any numbers. We did not have to do any long division or think about times tables. We didn't have to do anything numerically challenging in this one. We just played with letters. Let's take our steps and try again. Did I tell you there's 3? No, there's 4 in this one. 104 point, what am I on? Just 2? Oh man, all that work for just one problem. That's okay. Find B. Again, John has to tell us what to do or we would have nothing to do. I don't always write find, but I recommend you always write the letter you're looking for at the top of the problem and circle it because it's easy to get distracted and forget, what am I doing here again? Because you're just shoveling letters back and forth across the page. Plus CD equals X. Okay, so we're trying to find B. It's down buried in the bottom. Don't even worry about that yet. Don't even worry about where it is and what you're going to do about it. Just blow up the denominators. And the way we do that is with the LCM. It's just going to be B times D. So there's no grand strategy here to save a particular letter. We just always do it the same way. Find the LCM, get rid of the denominators, and then let's see what we've got. Okay, the B's cancel, and I have AD. The D's cancel, and I have BC. See how I'm making them alphabetical? Isn't that fun? Oh, I can't hear. Nothing cancels, so it's going to be X, B, D. We need to say right at the beginning that B and D cannot equal 0. John states that in the problem. It's written in the book, so we don't have to worry about that. Okay, so now I've got AD plus BC equals, I'm going to put it alphabetical now, B, D, X. Beautiful. All right, we're trying to find B. So let me take a look at where my B's are. It will be easy enough, just subtract that over. This is gone. And now we have AD equals BDX minus BC. It's bad case alphabet soup, right? Now we're ready to factor out the B. And we're left with dx minus c This side doesn't change. Now, there he is. He's so cute. Now we divide away the stuff we don't want. dx minus c over dx minus c. Now, here's my little trick that I like to do to make this easier. Instead of copying the whole thing over, it's kind of a mess right now, I'll just write equals b. I bring this over to this side, and then I can draw a neat box without having to recopy everything. Life is short. Let's not recopy. That's the right answer, but we have to set up one more impermissible value. dx minus c cannot equal 0. So we have to add that to our solution. John takes care of the beginning. I didn't even write it down. He writes it in the book. You'll see it. But at the end, we have to add our little bit. All right. Here comes a little wrinkle that I don't think is much of a wrinkle. Find x, okay? That's what I recommend you do. A over b. Now, let me show you. This problem has a number that doesn't have a denominator, right here. A over b minus c. See how the c is floaty? I'm not having that. I don't like that. So I'm not going to put a denominator on it because I don't think we need it, but I'm just going to bump it up so that it's clearly in the numerator. And look, you can see here, here's how John sets the impermissible values for us in the beginning, but we have to do them in the end. All right, that was last problem. This is the new problem. So he takes care of us at the beginning, and we have to fix it in the end. All right, so I'm going to go minus c, I'm bumping it up so it's clearly a denominator, equals d over x. And he writes b and x cannot be equal to 0. Great. All right, we blow up our denominators by finding the LCM. It's just b times x. The LCMs are super clean and crisp in these problems. We'll multiply everything. Every term has to be multiplied. Not just the ones that have a denominator, but everything has to be multiplied. Otherwise, we're screwing things up. This cancels. I have ax. Nothing cancels in this one, so it's going to be bcx. Look, I made it alphabetical. And here the x's cancel, so it'll be bd. So I'm going to rewrite that. ax minus bcx equals bd. Now we want to get all the terms with an x on one side. And look, they already are. That worked out well, right? So now we factor out the x, a minus bc. The other side doesn't change. And then we divide away the part we don't want. That cancels. There's our x. And I just recopy it over here to make the answer look neat. BD minus, hang on kitten. I'm just checking to make sure it's right. Yes, and we have to set up our new impermissible value. A minus BC cannot equal 0. So that becomes part of our answer. Yay. Okay, pause while I fetch kitten. He's outside and crying. Okay, ready for one more? It's 104.4. And in this one, we're finding x again. It can be any letter. It doesn't make it harder or easier. If you see, like in this problem, a over x. We see our x's in the denominator. That doesn't make it better or worse. It doesn't really matter where the letter is because we're going to follow the same steps all the way through, and wherever that letter is, it will work within our steps. Okay, again, I have a floaty letter. I'm going to push it up to the numerator. I don't necessarily need to give it a denominator of 1, but I push it up. M over N equals K. And this time I've got 2. John has written that X and N cannot be equal to 0. Thank you. Now we're ready to find our LCM. And it's just N times X. I went alphabetical. You don't have to use a different color. I'll do it once like this. It just helps it pop a little bit if you use a different color. So if you find this confusing at all, or if you get scrambled, consider using a different color. I also recommend make sure you're giving yourself enough room to write these in. All right? The neater you can make your work, the less confused you will make yourself. The X's cancel, and I'll keep the N. Nothing cancels here, so all of this. And what I do sometimes is just leave it like that, and then I'll copy everything. Here the N's cancel, so I'll have an X there, and here everything stays. All right, so let's see what we've got. AN minus, I'm gonna go alphabetical, NXY plus MX equals KNX. All right, that's a lot. I'm looking for X's, so let's see. Here's 2, and here's another one, and there's the equal sign. So what I'm gonna do is I'm gonna swim these two across. I'm gonna use our change sides, change signs rule so that I don't have to show all these fish swimming. The AN will be left by itself over here on the left. First, I'm gonna do the KNX. Then I'll bring this one over. I'm gonna turn it into a plus NXY. And then this one will change into a minus MX. Okay? Change sides, change signs. Saves us a lot of writing and potentially introducing mistakes. Every time you rewrite something, it's possible, and this is true for me too, it's possible I could introduce just a copying error. So why keep copying things when life is too short? There's a better way, right? So now we're ready to factor out all these X's. The other side stays the same. And let's see what we've got. KN, right, plus NY minus M. Beautiful. Now we divide all of that away. We don't want it. We just want the X by itself. KN plus NY minus M. That all goes over this. That all cancels, and I'm going to carefully draw my box like this. Again, I don't want to have to recopy it. Let's see if I did it right. AN, yes, and then all I have to do is write my impermissible value that this whole big crazy denominator thingy cannot equal 0. Guess what? Right answer. Yay! We will be playing around with these a lot next year too. So this is just an introduction, and we will come back next year and do more. Okay, that's all. Thank you, goodbye.